Okay, so in this part, we're going to talk about how to graph logarithmic functions. To graph logarithmic functions, let's remind ourselves how graphs of exponential functions looked. And if you can remember, this is how an exponential function looks. It's got a horizontal asymptote, okay? And this is how the function looks, the graph looks. Now, in the case of logarithmic functions, the thing about logarithmic functions is that a logarithmic function is an inverse of exponential functions. So logs are inverses of exponential functions. And if you can remember, 2 chapters ago when we learned about inverse functions, to find an inverse function, the first thing we did was to switch x and y. And what we did after that was we said, okay, if that's the case, if we switch x and y between a function and its inverse, then the domain of the function will become the range of the inverse and vice versa. So everything associated with the x goes into the y and vice versa, which means anything that had to do with, horizontals now becomes verticals and so on. So if an exponential function had a horizontal asymptote, a logarithmic function then will have a vertical asymptote. So if an exponential function had a horizontal asymptote at y equals 0, this logarithmic function has an asymptote, a vertical asymptote at x equals 0. Okay? Which means, okay, let's talk about domain and range. For exponential functions, domain was all reals, but for logarithmic functions, that switches, so the range is all reals. And the domain goes from the asymptote to infinity. All right, so a logarithmic growth function looks like this, and a logarithmic decay function looks like this. Also has a vertical asymptote at x equals 0. Okay, the range again is all real numbers, and the domain is from the asymptote to positive infinity or from negative infinity to the asymptote. Okay, let's talk about graphing a logarithmic function. All right, so again, we're going to use these properties of inverses. So a logarithmic function is written like this. We have a log base 2 of x. One thing that's easy to do is you can rewrite it as y is equal to log base 2 of x. And now remember, let's stick with this thing of, switching x and y. So remember when we were graphing exponential functions, we picked values for x, right? We picked values for x. Now we're going to pick values for y. All right, so for y, I'm going to pick values of -1, 0, 1, 2, and so on. Okay, and now these will be the exponents. Okay, and now let's go into our logarithm. Where is the base here? The base is this number 2. Right? That's log base 2 of x. So the base goes here, and here we have 2 to the -1, 2 to the 0, 2 to the 1, 2 to the 2. So finally, this will be 1/2, 1, 2, 4. So now let's graph this. The asymptote is going to be at x equals 0. So let's graph this. When x is 1/2, let me put the asymptote here. When x is 1/2, y is -1. When x is 1, y is 0. X is 2, y is 1. X is 4, y is 2. And it looks like this. Okay, So the domain for this is 0 to infinity. The range is negative to positive infinity. We're not going to talk about y-intercept for this one. Okay, end behavior. So I made some typos here. So as x approaches positive infinity, f of x approaches positive infinity, and as x approaches 0 from the positive side, f of x approaches to negative infinity, and it's continuous from 0 to infinity. Okay, let's do another one. Here I have log base 1/3 of x. So this is basically y equals log 1/3 of x. So again, we're going to say the asymptote is x equals 0, and we're going to pick values for y, okay? -1, 0, 1, 2. All right, so here it's going to be 1/3 to the -1, 1/3 to the 0, 1/3 to the 1, 1/3 to the 2. So 1/3 to the -1 is 3, 1, 1/3, 1/9. So when x is 3, y is -1. Okay, let's put the asymptote first. When x is 3, y is -1, 0, 1, 1/3. When x is 1/3, y is 1. When x is 1/9, y is 2. So this looks like this and that. Okay, so again, the domain goes from 0 to infinity. The range is all real numbers. I'm not going to talk about intercept. The end behavior as x approaches positive infinity is negative infinity. As x approaches 0 from the positive side, it's positive infinity. And it's continuous from 0 to infinity. Okay. Now, for this next one, I have ln of x plus 2. Okay, so this is y equals ln of x plus 2. Now, notice there is a horizontal shift here of plus 2, meaning everything has moved to the left 2 units. Everything including the asymptote. So the asymptote is now at x equals -2. Okay. And for this one, the base is e, right? Since the base is e, this has to be done with a calculator, right? We can't do these by hand. And you know, when it comes to graphing logarithms, all I want you to do is just plug the entire logarithm in here. So we're going to do this is equal to ln x plus 2. Enter. And that's what it looks like, right? So now what I want us to do is just, trace and pick some points here. So let's see. I go menu, number 5, trace, number 1, graph trace. And let's just type in some points. So -1 is 0. Okay, and I like to write here -1, comma 0. And then let's see, maybe 2 is 1.38. 2, 1.38. You can pick any 3 points. Let's do, I don't know, 6, just random points, 2.08. And it will look like this. Okay? All right. So you don't really need to do a table for this one. It's just good enough to do it that way. The domain is -2 to infinity. The range is -infinity to infinity. Let's not talk about intercept for now. As x approaches positive infinity, this is positive infinity. As x approaches -2 from the positive side, it goes down to -infinity. Okay, and lastly, let's do this one. So again, we're going to graph, but this time we're going to graph ln of x tab, let's see, ln of x minus 3. So that looks like this, okay? So this one does not have a horizontal shift. So the asymptote is still at x equals 0. We have a base of e. All right, so let's see, asymptote here. Let's pick some points. Menu 5, 1. Let's type in 1 is -3. Let's do maybe 3 is -1.9. And let me do, I don't know, 9. Just being rebellious here, going all the way over there, -0.8. Whoops. That became an infinity. Okay. All right, so it looks like this. Okay, so as x approaches positive infinity, since we're here, this goes to positive infinity. It might look like it's going to level off at 0, but I promise you it's not. Like if you go further and further down the road here, you see that it is increasing gradually but surely, but just increasing all the time. As x approaches to 0 from the positive side, this goes down to negative infinity. The domain is 0 to infinity. The range is all real numbers. And that is the lesson for this part.